Today's lesson is on the point-slope form of a linear equation. So we have learned slope-intercept form, y equals mx plus b, and we've learned standard form, ax plus by equals c, and now we're into point-slope form. And it's called point-slope form because just from the equation, we know the slope and we know one point on the graph. So, m, just like always, is your slope. And then the point comes from y1 and x1. And then your variables, x and y. Now let's work on graphing the linear graphs from equations that are in point slope. So usually we would start with the y-intercept and then use the slope. But in this case, instead of starting with the y-intercept, we're starting with another point. So the point that we're going to use comes from our equation. 3 matches up with x, and then the number 2 matches up with y. So we have the point 3, 2. So let's graph that point over 3 up 2. And now we can use that slope, m equals negative 3 over 2, and we're going to start from that point. So from this point, we're going to go down 3, right 2. Down 3, right 2. And then we can go backwards, up 3, left 2. Up 3, left 2. So let's connect. And here I've graphed the linear graph for this equation. You find the point and use the slope to get other points, and then you can graph the line. Here we have another equation, example number 2. We're going to use the same idea, but this equation's a little bit different. I want you to think the actual equation is y minus y1 equals m times x minus x1. So the formula has subtraction signs in the formula. So what do you think would have to be true if all of a sudden you have a plus sign? What that means is if you had, let's say y minus 2 equals 3 times, it would be x minus, and then instead of 2, it would be negative 2. So when you have a plus sign, you want to think the number that corresponds to the ordered pair is going to be the opposite. Because to make a plus sign, you would need that double negative. So the point is the x value negative 2, and then the y value positive 2. So basically, if you have a plus 2, it means negative, and if you have a minus 2, it means positive. It's opposite. So let's plot the point, negative 2 up 2, and then we have the slope 3, so 3 over 1. So from the point that we graphed, we're going to go up 3 over 1, up 3 over 1, and then go backwards, down 3, left 1. And then we can connect. Okay, I want you to try this one on your own. So go ahead, write it down, and think about how you would graph it. So x value, because it's minus 1, that means we have a positive 1. And then the y value is because it's plus 3, it means we have a negative 3. And then slope is negative 2. So plotting the point given and using the slope to get other points, you should have graphed this line that represents this equation. Alright, so now we're going to practice all three forms of the linear equation. And all we're given are 2 points, because you can create a straight line between any 2 points. So we're going to write the equation that represents the line between those 2 points in point-slope form, and then from there we're going to change it over to slope-intercept form and finally to standard form. So, point-slope form. First, let's find the slope between 2 points. Let's find the change in the y values, 8 minus 7, divided by the change in my x values, 6 minus 5, which is 1 divided by 1, which is 1. So my slope is 1, and now I need to pick one of the points. It does not matter which point. So what that means is you can choose whichever point. So you can have different point-slope form equations depending on which point you pick. But by the time you change it to slope-intercept and to standard, no matter which point you choose, they will look the same. So I'm just going to choose the first one. Let's plug in these numbers. Y minus, and then my y value is 7, equals 1 is my slope, times x minus my x value is 5. So here I have an equation written in point-slope form. And I'm going to change it to slope-intercept form, which is y equals mx plus b. So basically I'm taking my equation and I am solving for y. To do that, I'm going to first distribute, because I have that set of parentheses. So y minus 7 equals 1 times x is x, and 1 times negative 5 minus 5. So now to get y by itself, I need to add 7 to both sides. So y equals x, and then negative 5 plus 7 is a positive 2. So I have changed my equation from point-slope form to slope-intercept form. And now the last step is to change it to standard form, where you get x and y on the same side of the equation. So I need to subtract x to the other side. So I'll have negative x plus y equals 2. But remember, the leading coefficient can't be negative, so I'm going to multiply everything by negative 1. So it's positive x minus y equals negative 2. And that is my equation in standard form. So whether it's in point-slope form, slope-intercept form, or standard form, they will all graph the exact same line. Let's go through this example together, and then you can try the last two on your own. So first, point-slope form, we need to find the slope between 2 points. So we need to find the change in the y values, 12 minus 8, divided by the change in the x values, 2 minus negative 4. So this becomes, let's see, 12 minus 8 is 4, and then 2 minus negative 4 is 6, which reduces to 2/3. So my slope is 2/3. To write my equation in point-slope form, you can choose whichever point that you want. I'm going to choose the first point so we can get some practice with a negative number. When you plug this in, y minus the y value of the point is 8 equals m is your slope, 2/3, and then x minus negative 4, because it's a negative, that double negative is going to make it x plus 4. So we have point-slope form. And now we need to change it to slope-intercept form, y equals mx plus b, and we're going to do that by first distributing the slope. So y minus 8 equals 2/3 x, and then 2/3 times 4 is 8/3. To get y by itself, I need to add 8 to both sides. So y equals 2/3 x plus, let's go over here so we can do 8/3 plus 8. Well, let's change 8 to a fraction with a common denominator, which is 24/3. So now when you add 8 plus 24, you get 32, and that's 32/3. So there's my equation in slope-intercept form. Now let's get it into standard form. So we have to get x and y onto the same side. So I'm going to subtract the 2/3 x to the left side plus y equals 32/3. But remember, my leading coefficient cannot be negative, and then I cannot have any fraction. So I'm going to multiply everything by a negative, and my denominator is 3. So negative 3 times a negative 2/3 is a positive 2, so 2x, and negative 3 times y minus 3y equals negative 3 times 32/3 will be negative 32. So I have point slope form, slope intercept form, and standard form, all graphing the exact same line. Here are the last two examples. I want you to pause the video and try them, go through all the steps, and then come back and check your answer. So here are all the different forms of the equations that go through the points given. So check your answers. I hope you did well. And just know that even though these are all written in different forms, they all represent the same line that goes through the given points. There's just lots of different ways to write the equations: point slope, slope intercept, and standard form. Good luck with the lesson.